My name is Jessica Tarosian. I am a recent graduate of the Helmuth Lab at Northeastern University, and I am currently an operations research analyst at the U.S. Department of Transportation's Volpe Center in Cambridge, Massachusetts. We are standing in Revere, Massachusetts. This is the Rumney Marsh. Specifically, we are standing right next to the Oak Island Tide Gate, which is behind me. We are on the downstream side, so what happens is the ocean sort of is that way, but somewhat counterintuitively, the ocean comes in from this side and then goes through the tide gate. So this is the downstream side, and on the other side of the tide gate would be the upstream side.
Yeah, I'm not the best guy for the exact acreage, but I know Rumney is quite a few thousand, maybe 3,000 acres? I can't remember its actual acreage. It's up in that kind of range. Area of critical environmental concern. From my perspective, both from the fisheries service and as a recreational fisherman and recreationist, everything takes place out here. I'm Eric Hutchins. I'm with the National Marine Fisheries Service, actually the NOAA Restoration Center out of Gloucester, Massachusetts. That's our field office. I'm actually a headquarters office, but I work throughout the Gulf of Maine, and my focus is habitat restoration. The site that we're at today is actually one of my long-term sites. I go back about 15 years here at Oak Island. It might be even closer to 20 years now working at this site. Once you start working on a site, you're there forever.
Okay, we're at the Rumney Marsh wetlands. This is the marsh area right here. And this side is where the MBTA commuter rail separates that side of the wetlands from this side of the wetlands. Matthew Martelli, I work for the City of Revere Water, Sewer and Drain Department and everything. I'm more into the water. But I've been working with this tide gate for a number of years and everything, so I know basically its operations. Now, we want to keep that side of the wetlands wet because we want it for conservation and to keep the animals, you know what I mean, to keep nature the way it's supposed to be. But we can't let too much water in there because we have a neighborhood that's right over here. So we put a sluice gate in. This is called a sluice gate. And what it does is it opens up as the tide's coming in. It'll let the water get into the basin on the other side over there, up to a point where it's just before it can cause any flooding, and then the gate will close. And the tide will come up to a certain extent and everything. And then when the tide goes out, the gate will open up at a certain level and let all the water out.
So tide gates are used usually as a piece of coastal infrastructure, usually where there's some sort of transportation corridor and some sort of other development that you need to prevent from flooding. So typically, as the tides come in and out every day, occasionally there will be sort of higher tides based on moon cycles and lunar cycles that can cause some flooding events, which is happening more frequently now with climate change, but also large storm events like the hurricane that just came through recently, Hurricane Ida. As you can see where I'm standing, this was all underwater at some point. And so to protect the homes on this side of the tide gate as well as the roadway, people will put tide gates in to just kind of prevent houses and other infrastructure from flooding.
That's our problem. When it comes to the city, that's our main concern, is the public, what I mean? Keeping them from flooding and stuff. We want the wetlands, we understand what's going on with it all and everything, but we just, we really don't want that area to flood.
There will always be a threat living here. I hate to refer to it this way, but I often do. I often describe this area in particular of Revere, behind Oak Island in particular, as the New Orleans of the North. There's that many houses that actually live below sea level above this tide gate here. Many of the residents don't actually know they're below sea level. They just don't know it. I've talked to them, why is this water here? They don't actually know that many of them are 2 to 3 feet below predicted tide levels. And it's this railroad embankment that's actually keeping the water from getting over there. That
area can flood very easily. At one time, that area was just cottages. For when this was like the Revere Beach Wonderland with all the rides and everything else. And then people started building houses there out of the cottages, and it became regular neighborhoods. Wow. So it was always below like the water level, It's a pretty simple operation, basically. The thing opens, it lets the water get to a certain level so the wetlands get saturated. It doesn't let it get too high so it doesn't flood the neighborhoods. Closes, water empties out, opens again when the water starts coming back in again. It works great.
A lot of these tide gates were built back in the early 1900s and in some cases late 1800s. This site was dry stone granite blocks probably from Rockport, because this end of this line runs right to Rockport. They probably built the box culvert with granite from Rockport when they built the line back in the 1800s. At first, it probably had no tide gate on it for years, and then as people settled in the low-lying areas around the marsh here in Revere and other locations, people said, why not put a tide gate under it? And that's what they did. They put a flapper gate, just a simple wooden flapper gate that allowed water to go one direction. Water could drain out, but it couldn't go in, though it could always go in through a little bit of leakage. These tide gates were never perfect. So some of the creek stayed alive, fish stayed in there, but they in essence lowered the water level, the average water level upstream of this tide gate, probably by 3 feet, which means, as an example, looking on this side, all of that green no longer was seeing salt water. So over the years, it didn't take long for this plant, invasive, you probably have some pictures of it, invasive Phragmites australis, to take over that drained marsh on the other side. So when I first got involved here 20 years ago, no salt water other than in storm events was reaching the marsh surface over all of that acreage on the other side of these railroad tracks, except in the creeks, the depressed creeks. And even then, a lot of that was just storm water off the streets and highways and railroad beds around here. So it was really garbage water that sat there stagnant and only drained when it rained again, or if the water level went low enough here. So it was about as bad as you could get. Tide would come in, it couldn't get in and refresh it. So it got hot, stagnant, and probably a lot of chemicals and nutrients and everything else you don't want to think of. So the project that we did here, working with the city and many others, was to get additional flow up there that basically raised the water level as high as we possibly could on the other side, as well as some regrading. So bringing the grade down, bringing the water level up, and getting flushing in and out through a new culvert and a new tide gate. So with that work, we've now at least opened up quite probably 1, 2, 3, 4 acres of restored habitat that didn't exist on the other side. It was uniform Phragmites with no fish habitat. What I usually tell people is, if there's no water, there's no fish. It's as simple as that. It's not that it's still a wetland. A wetland full of this plant may be great for carbon sequestration, which is good for that. But with salt marsh plants, we get carbon sequestration and fish habitat and bird habitat at the same time. Since the work took place about 5 or 6 years ago, I just took a peek when I arrived today. It looks beautiful. The area that's been worked on actively looks like uniform Spartina alterniflora, which is this plant down here, the low marsh species that grows 2 to 3, 4 feet high, and it looks beautiful. I didn't take a close look, but at least from a distance, looked great.
So a healthy marsh really, plays sort of a multifold purpose for the communities that reside around it. A healthy marsh is really helpful, first of all, for providing food for a lot of the fish that people will eat. So there's a lot of forage fish and smaller species like the mummichog that feed things like the striped bass and help kind of keep the ecosystem healthy. They feed the birds that come through this area. All of that sort of helps, facilitate this vegetation that we see here. And a healthy marsh really does have kind of these 2 levels of Spartina with some upland vegetation, and sort of the structure of the marsh and the way that it interacts with the water that comes in and out allows it to to sort of absorb water, so it can help actually ameliorate flooding, and it also can buffer storm surge and wave energy, so it can actually kind of prevent some damage for the surrounding area and help improve infrastructure resilience. So the tide gate's trying to protect the community by trying to prevent flooding. However, if it's interfering with the normal ecosystem function of the marsh, it can actually degrade the quality of those surfaces that I just mentioned. So if the fish aren't surviving and they're not sort of, pooping and being eaten, then it's not going to help do the right fertilization for the marsh plants. If there's too much eutrophication runoff from fertilization and other pollution can affect the root structure of the plants. It can cause these marsh beds to collapse in, making them less effective at sort of buffering against flooding, less effective at buffering against storm surge, and in the long run, it can also affect the ability of this marsh to respond to sea level rise and climate change. What we really wanted to try to do was kind of look at this from a multifactorial or multifold angle. So trying to understand how to better manage the tide gate so that it's more effective for the people that live in this area that are protected by it. And that means both understanding sort of what it's doing to the ecology, because making sure that this ecosystem is functioning properly will allow it to provide the best ecosystem services for the people that live in the area, but also make sure that the tide gate's being engaged properly to prevent things like flooding.
There's absolutely the opportunity and a certain level of implementation already at this site for win-win for private property owners, commercial industry, infrastructure that's maintained privately, as well as railroad lines and the Department of Public Works for their water and sewer here. All of those have the potential of win-win at this site with proper management of this tide gate. That's not easy. I'm not gonna say it lightly that it's just easy to, it's not turnkey. You don't turn the key on and walk away and everything's fine and dandy. The key is they have the ability to get elevated levels of salt water in here that impact nobody. Getting salt water up on the marsh surface, killing out invasive species, bringing in birds, which is aesthetically nice, knocking down this. This plant alone has caused as much damage as not necessarily, but a lot of damage in Revere because it burns unbelievable. In the spring and fall, it's almost a rite of passage. Sometimes people say little kids going to school on their way to school throwing matches. I don't know if that's always the case, but sometimes it's the case with kids lighting fires. Sometimes it's a cigarette out the window. And you know what else also starts fires here? Railroad lines, metal on metal. Sometimes a wire hangs and it's sending sparks out. That has started many fires on railroad lines. But when you have a huge patch of extremely dense Phragmites, it has burned so hot that many of the houses right here behind you, the siding has burned off them. The vinyl siding has literally melted off of them. I think in some cases, I think some houses have burnt in Revere, but I've seen the pictures of multiple burning. So getting rid of this plant gets rid of a fire hazard without a doubt. Another advantage to the town, besides fish and fires, is mosquitoes. Nobody likes mosquitoes. Nobody likes spraying. Nobody wants to be breathing pesticides and herbicides. By bringing salt water in, we knock this plant back, we raise water levels. Raised water levels in here no longer makes it mosquito breeding habitat, and you just let nature do it. Now the win-win, where management comes in, we got a storm coming like last week, the permit for this site gives full ability to the Department of Public Works. We have a predicted storm. National Weather Service says there's a possible tropical storm coming like last week. They have all the ability and right in the world to come down here, turn the machine on, put it in one-way mode. Let the storm pass. All of this ends up getting used as flood storage in case waves come over the barrier or heavy rain comes in. Just for that short amount of time, as soon as the danger has passed, open the gate back up. That water, that flood water passes out and the normal tides go back in. The key is they got to remember to turn it on, because sometimes here and everywhere, when a storm's coming, DPWs everywhere have got a lot to do. And sometimes a tide gate is not the first thing on their mind. They got to be putting plows on the front of trucks. They got to be loading sander trucks. They got to be putting sandbags. And sometimes they're not thinking about this. So if you forget, oops, and then the tide comes in, you might not have access to even turn the gate off. So management is the key thing. And then when the storm is passed, the key is to come out quickly afterwards, open the gate back up so the salt water can stop flowing again. But absolutely an opportunity, at least at the details of this site, for win-win for everybody.
So I think to really understand what was happening at the ecology level, we need to be able to understand what's happening with a variety of environmental variables. So one of the ways we did that was to install the weather station that is installed in the cage in the tide gate behind me. That allowed us to get sort of basic weather variables like air temperature, solar radiation, precipitation levels, wind speed, that we could potentially use, especially if we could monitor that with times that the tide gate was engaged, to see if there were any kind of advanced indicators that might allow us to better manage how the tide gate is used and when it's triggered. But those parameters are also going to be really useful in understanding how weather and how the water quality is affected by the tide gate use. So in addition to measuring those sort of above water weather variables with the weather station, we also had a monitoring effort where we would measure salinity, dissolved oxygen, and water temperature, and also the tide height on both sides, so that we could understand sort of how, when the gate was open or closed, it was affecting those sort of very basic water quality parameters.
Hi, I'm Mark Patterson. I'm a professor of marine and environmental sciences and civil and environmental engineering at Northeastern, and I also serve as the lead principal investigator on a study that was funded by the National Science Foundation to help develop best practices for tide gate management. What we're standing next to is a telemetry station that we've installed here at the Oak Island Tide Gate in the Rumney Marsh. It's an off-the-shelf unit made by Onset Computer here in Massachusetts. A lot of what we see here is measuring things related to the weather. We've got a way to measure rainfall, air temperature, wind speed and direction. We can look at how much sunlight is hitting the marsh and how much of that is infrared. We can also measure relative humidity. Why we're interested in the weather is that the weather greatly affects what's happening with respect to water flow in a tide gate. You can imagine that we would like to know how much rain is arriving, because that may impact how much water is stored on the upstream side of the tide gate when the gate is closed. In order to see this data in real time, we have under this black container a link to the cell phone network, and there's a big battery there that's running everything and is also being charged by the sun when it's out. We also have sensors going in to measure water depth as well as water quality, and I'll show you some of the unique challenges we have at this site, because we've got a commuter rail behind us here, and the other side of the tide gate, which is the fresher water side, we'd like to get telemetry from as well, and I'll show you the solution we came up with. Some of the challenges we've had with the system have been vandals, probably kids, throwing rocks at the infrastructure here. They've broken the wind speed indicator, they've cracked a solar panel. So we have put up signs, they're actually not up today, saying "Smile, you're on camera," even though we don't have a camera here. We did have a camera to look at wildlife use in the marsh earlier. Anyway, it seems to have acted as a deterrent so far. Tide gates are attractive nuisances for people who are out running around in nature, essentially unsupervised, because the police never come here. So this is a real world issue if we want to have an Internet of Things trying to understand what's going on at the tide gate.
So when we started sampling, initially the gate was open and closing as it should, but pretty quickly into our sampling, the tide gate actually failed in the closed position, which allowed for sort of a natural experiment for us to kind of understand what would happen if something like that happened. And so when the tide gate fails in the closed position, it's really preventing passage of water from the ocean to the upstream side. What we saw there was that after the closure, it pretty much freshened very quickly, so the salinity dropped significantly. The water level wasn't changing as much. Dissolved oxygen became much more variable at different depths, and also a lot lower. And also the temperature also became a lot more variable, but definitely got a lot higher, especially in the summer months.
Failure in the closed position will not cause flooding.
Right.
A failure in the open position, then we are in problem. Like it says, it could be a sensor, it could be the motor, it could be a number of different small things and everything that we try to keep on top of. But it's happened once or twice, you know. And sometimes, I think one time we had a failure, there was a big log that was stuck underneath there or something. I don't know how it got in there, you know.
Mechanical machinery will continuously break. And look at these conditions. Northeast United States, winter storms, saltwater influence continuously, icing. Icing north of Cape Cod is a significant impact to tide gates. We get chunks of ice on a bad winter still, even with climate change, that are sometimes 3 feet thick in here. Sometimes ice forms inside the barrel of this culvert. That machinery can come down and actually hit the ice and stop. So those potentials exist to break the machinery. Even though there's a fence and barbed wire around it, I think people that even have equipment in there know that for some reason, large 2 to 3 pound boulders often get thrown up and over that fence and land on the equipment on the other side. And that's just something that is part of human nature, unfortunately. See a fence, have rock, throw over. I've seen a number of culvert, machinery, and project sites broken that way. This is a out of sight place. I mean, no, the police don't come down here. Nobody comes down here. The gate is usually closed, but vandals can come down, and vandals can reach many tide gates, and that's often an issue. The pieces break. They just simply break, unfortunately.
What's nice about this telemetry system is that it talks over the cell phone network to a server at the on-set computer. And we can actually see what's going on in real time. So I've actually logged into the system right now, and I'm looking at the elevation from one of the tide sensors that's measuring water level. And we can see it going up and down with the tidal changes. And this ability to see what's happening out here in real time and to also gather large amounts of data was part of the motivation for the NSF study, because we wanted to understand exactly what's happening with the water quality, exactly what's happening with the weather at this gray infrastructure that's embedded in all this green. And are there things that could be done to maximize ecosystem health while minimizing the risk to the residents around here from the two primary risks, which are flooding and fire from the invasive grass Phragmites. Right now, most tide gates, if they have sensors, they're usually just the water level on the upstream and downstream side of the gate. The next thing of interest to agencies like NOAA or Department of Marine Resources or Conservation in any state is, what's the water temperature like? Because that's the biggest driver of the physiology of important species like the forage fish that use the marsh as a nursery. And my colleague Brian Helmuth has been doing a lot of work trying to understand how differences in temperature, just slight differences in temperature, can lead to big changes in physiological performance in things like killifish and some of the other forage species here.
Yeah, so one of the other ways that we were sampling the environment was to try to understand sort of how those environmental parameters changed with depth, but also how they changed as you moved away from the tide gate. And to do this, there were several members of the lab that were involved in a sampling process where they would attach sensors to a kayak and kayak kind of away from the gate on both sides. And they also were able to use a small open source underwater vehicle to measure different parameters at different depths. And so through this analysis, we were able to see, somewhat surprisingly, that there was a lot more sort of like heterogeneity in those parameters than you would normally expect, especially over fairly short distances and fairly small depth changes. So one of the key takeaways, I think, sort of once we started looking at the data and seeing how there were really drastic changes in the environment on both sides that kind of led into drastic changes in what we were seeing in terms of species assemblage. We wanted to understand how this might impact sort of even sublethal survival or sublethal stress on a particular animal, in particular the mummichog, which is an indicator species for the marsh, and it's actually was found on both sides of the tide gate even after the failure in the closed position. And so to do that, we, the lab, not myself, other researchers, parameterize what we call a thermal performance curve, which tries to understand how an animal functions sort of across the range of temperatures that it would normally encounter in the wild, or even not normally encounter in the wild. You usually sort of want to push it past that to understand what the breaking point might be. And what we saw was that on the downstream side, where the water is getting refreshed every day and the temperatures were staying kind of with a lower variability, the parameters of the thermal performance for the mummichog was sort of well within the temperatures that it was seeing on the downstream side. But when you looked at the temperatures that they might be experiencing on the upstream side, it was really reaching those lethal limits of that thermal performance curve, both in terms of sort of its break point at the top of the performance curve, but as well as sort of where it might start to decline and eventually die. So the more it's exposed to those kinds of conditions, sort of the less able to survive the species will be, or that population would be able to survive.
Another collaborator who's not here today is Loretta Fernandez, who's in the Department of Civil and Environmental Engineering. And because this ecosystem you see behind me has been used by humans for hundreds of years, there are a lot of contaminants in the sediments. And Loretta's a chemist, an environmental chemist, who's really interested in understanding how much the tide gates affect the movement of contaminated sediments in a system like this. And that's something that can affect the health of species that live in the marsh, and it's a big open question right now. One other benefit of instrumenting tide gates and trying to capture data 24/7 despite all the hiccups we're having is that we can use machine learning to understand these big data sets, and in particular how we might be able to add value to places like the city of Revere who have a tide gate to monitor is while they do have real-time sensors that let them know if the gate has failed, and they can send out a person to address it. It'd be nice to know in advance if something is about to go sideways. And both with self-regulating tide gates or electrically operated sluice gates like this one here, sometimes there might be signals in the data. We looked at the data that were collected on water elevation prior to the failure of this particular gate that happened about 6 or 7 years ago. And it looks like there were some signals showing that the gate was starting to misbehave. It was probably the gate itself that has to travel on this rack was getting hung up. And so we were getting some interesting asymmetries in the water elevation. Could we also do that using water quality as our early warning indicator for things going awry? That's a question that we'll be following up on, even though this NSF study is now over.
I think one of the things that we saw in this system is just sort of how fast tide gate closures really do start to affect the environment, and trying to understand what the cumulative effects of that happening over and over again, or even in this case, if it fails in a closed position or in an open position, what the long-term implications are from an ecological perspective, and how that might affect things like essential fish habitat or other fish species that might be managed, or even some of the managed migratory birds that come through this area. How are they being impacted by these sort of short but maybe frequent disruptions to what a normal environment might look like for them? And I think that you can really see sort of how there is that sort of like, it's a two-way street where, you know, you don't want to compromise the integrity of the marsh to the degree that it's no longer providing the function that it also serves to also help kind of absorb water and prevent flooding. I've been on this side of the marsh during an extremely high tide event, and the gate has been closed, and the water comes very, very close to flooding the train tracks. I've seen rodents swimming through the flooding water as the tide comes in. And so you have to be careful. If you close the gate too early, it could, in addition to causing some ecosystem issues on the other side, it can also sort of preemptively cause flooding on this side if you don't let enough water go through. So there's sort of kind of a two-way, it is sort of a two-way street, and you just kind of, it's not an easy solution. And I think hopefully by gathering more data and understanding kind of what happens from a weather perspective as well as from an environmental and ecosystem perspective, we can maybe start to make better decisions and maybe even help design better structures that could be used more effectively in the future.